Hi everyone. So we are on week 2 of our distance learning. It's a similar format as of last week where you're going to go through and fill in these vocabulary terms. Then we're going to talk about them and then we're going to do some example problems. We'll meet in our live Teams meeting, do some more example problems, and then you'll get started on your homework and your IXL. All right, so we are now diving into geometry. So geometry is, make sure we fill that in, the study of points, lines, and planes in space. So some of this should be a review for you. And then we're going to kind of build on and do some algebra towards the end because this is a pre-algebra course. So take a moment. I'm going to zoom out. You've got that table there. Go ahead and pause the video and you can fill out those definitions. So take a moment, pause the video, fill out those definitions. Okay, hopefully we are back after filling out the definitions. So a point is the simplest figure in geometry. So usually with a point, you're going to see a dot in the diagram with a letter like A. Okay, so the way we note it, or the notation, would just be a capital letter. Okay, so we use capital letters for points. A line goes on endlessly in both directions, and it's actually made up of a whole bunch of different points, all kind of squeezed up shoulder to shoulder from each other. And then on this line you're going to have letters. So let's say there's C and let's say there's B. So the way that we're going to talk about lines is we're going to pick 2 points on the line, so C and B, and then to say that it is a line, we are going to draw a line over top. You don't have to go in that order. You could also write it as B C with a line over top. So order does not matter as long as you put that line over top. An endpoint is an endpoint is a point that stops a line. So once again, it's going to be a point that stops a line from going on. So we'll call it D, and you would be labeling it as a point D. Array. I actually created array right there. So this is array. I'll make it go maybe in opposite direction. It has one endpoint there. So the endpoint, redraw that. My lines are very shaky for right now because of my table. So we'll call that D, and then it's going to go out and continue on in another direction. So we'll call that A. So it's part of a line that has an endpoint, and the endpoint would be D, and it goes on in one direction. Now the order that you're going to name the ray is important. You always have to start with the endpoint where it ends, and then you pick another letter or another point on the line, and then you draw a little ray over top of it to say that you're talking about the ray DA. Line segment, you stop a line in both parts. Okay, so you have 2 endpoints that stop the line, so we can call that A and B. Order doesn't matter because you have 2 endpoints and you draw a line segment over top. Or you could write it as BA and draw a line segment over top. A plane is a flat surface, so usually what you're going to end up seeing it look like is kind of like a parallelogram, and it's going to have a little letter in the corner. It's a flat surface that, as we scroll down, I can show you another example. We've got a plane right here. Okay, so that's an example of a plane. It's a flat surface where you put points and lines on top of it. And we don't use M, we actually write the word plane with an N, plane, M. Because if you just use an M as your notation, you're going to be talking about a point because points are labeled just with the capital letter. So you want to include that word plane in front of it. And the last thing is an angle. So we've seen angles before. I'm just going to zoom in so I can draw a good one. So what angles are is they're actually rays that connect. Okay, they connect at the same endpoint. So if we're going to call this endpoint A, and A is called the vertex, and this can be C, and this can be B. Okay, so that is going to be our angle, and there's actually 3 different ways I can label this angle. I can call it angle A and just use the vertex that's there, or I could use 3 letters, CAB, and you kind of go in order, so angle cab, or you can go the other way, BAC, angle back. Okay, we're going to do some notation first and then we'll move on to some algebra. So the first thing, using this picture, they want me to name 3 points. Well, J is a point, so I'm going to use a capital letter, L is a point, and K is a point, using capital letters. P is not a point. This is not a point because it doesn't have a dot next to it. It's called the plane. So you would call plane P. right there, that would be the labeling of my plane. And then 2 lines. So since it says lines, I have to make sure that I put the line notation over top. So that's going to be important for your IXL. So JL is one of them. Yes, you could have also written LJ backwards. And KL is another. Yes, you could have written LK, gone the other way, as long as you have the line over top. All right, looks like I have an angle here, so I'm going to name 2 segments and their lengths. So segments means that I need to have the actual segment line over top. So MP here is a segment, or you could call it PM, and its measurement, which I'm going to write it next to, is 4 centimeters. And then I also have another one here, P to N, or you could have done NP, it doesn't matter the order, and that is 6 centimeters. And then 2 rays, so these would be very similar, except you're going to start with the P because the P is the end point, and you're going to move on to M. So PM, and then you write a ray over top of it because they're asking about the ray. Or it's P to N. So PN with a ray over top. And then my angle, you can name it any of the ways, but I'm going to make it easier on us. I'm going to call it angle P, or you could have written angle MPN going in the circle this way, or you could go in the circle the other way and do angle NPM. They're all good, and it is 80 degrees. Next thing we're going to talk about is we're going to talk about these words that you've heard over and over and over and over again. So acute angle, obtuse angle, straight, and right angle. So the unit in which we measure angles is degrees. An acute angle is between 0 degrees and 90 degrees, in between, so not including. It's not going to be a 0 angle or a 90 angle, it's all the ones in between. An obtuse is between 90 and 180. A right angle is exactly 90 degrees, and you're going to see that box there. Okay, that's important. That box can also tell us that this is 90 degrees, and you've seen that before in elementary school. A straight angle is a straight line, and it always equals 180 degrees. We talked about the vertex. This right here is an example of the vertex, and it is the point where the 2 rays meet in an angle to form an angle. Okay, perpendicular lines, this is when you have 2 lines here that intersect to form 90-degree angles. Complementary angles, so these are 2 angles that sum, remember the word sum means add, so I'm going to highlight that, they have to sum to 90 degrees. So sum means that they have to add. So if you look here, you see 30 degrees plus 60 degrees does add to 90 degrees. So these would be called complementary angles. Whereas a supplementary angle, they add to 180 degrees. So you've got 120 plus my 60 does give me 180 degrees. So that's why these would be called supplementary angles. We like to use the P's to help us figure out which one's which. So this was a while back. A kid a while back kind of went over this with me, but a P actually kind of looks like a flipped over 9. So if you turn it the other way, this would be 90 degrees. Whereas supplementary has 2 P's, so that's 290 degrees. 290 degrees makes the bigger 180 degrees. So you can kind of use that as a little bit of a hint there. All right, for these, we need to figure out whether the measurements are complementary, supplementary, or either. So I have to add them together to figure out what measurement they give me. So I'm going to go to my calculator and I'm going to add 53 plus 37. It gives me 90 degrees. So these are complementary. I'm just going to write comp for complementary. Whereas if I add these together, they're going to give me 190 degrees, which means that this is neither. If it was 180 degrees, I would be able to say that it is supplementary, but it's not. It's 190 degrees. All right, finding the missing measurement. Well, I see the box, so that means that these measures need to add to 90 degrees. So I can take 90 and subtract 71, and that's going to give me what that missing angle measure is, and X is equal to 19 degrees. Same thing here. This makes a straight line. Straight lines have to add to 180. So I take 180, I subtract my 113. It gives me 67 degrees. So my angle X is 67 degrees. Vertical angles are two angles that are formed when lines intersect each other. Okay, so when they cross each other, see how I have two lines there that are crossing? They're also congruent, which means the same measurement, and we can use a symbol for that too. So an example is 4 and 2. 4 and 2 are back to back to each other. 2 is going to be 100 degrees, and 4 is also going to be 100 degrees. So angle 2 and angle 4 are vertical angles. And then the same thing here with angle 1 and angle 3, they're back to back. They're also vertical angles. And I've got a straight line here. So see how I make a straight line? So these two angles have to add up to 180. So 180 minus 100 gives me 80 degrees for this angle and 80 degrees for this angle. So all those measurements are going to be two 100-degree angles and two 80-degree angles. And remember, a circle, which is kind of what I've created here, a circle has to add up to 360. So that's a way you could check that as well. You could add those up and they have to equal 360. All right, so here we go, same type of picture. I've got this measurement here is 125 degrees, which means opposite angle 3 is also 125 degrees. So I'm going to fill that in. And then you could use the 360 trick. So you could subtract these from 360 and divide by 2. I'm going to use that I have a straight line here with 1 and 4. So if it's a straight line, it has to add to 180. So I'm going to do 180 minus 125, that's what's going to give me the angle measurement of 4, which is also going to give me the angle measurement of 2. So if I go through and I subtract those, 180 minus 125 gives me 55 degrees. So 4 is 55 degrees and 2 is 55 degrees. And like I said before, they have to add up to 360. So go ahead and add all 4 of those angles up. They have to add up to 360 degrees. Okay, I think this is where we're going to probably spend most of our time during our guided practice in about a half hour or so, is going over these types of algebra problems. So these angles are either complementary, supplementary, or vertical. Complementary, they have to add to 90. Supplementary, they have to add to 180 degrees. Vertical means they are the same, they're equal. So let's start there. I see the box here, so that makes these complementary angles, which means that they have to add to equal 90 degrees. These are vertical angles, okay? So they are going to be equal to each other. Let me do that actually in a different color. So these are vertical angles, so they're going to be equal to each other. Whereas these angles here make a straight line, so these are going to be supplementary angles. They are going to add to equal 180. So that's how we're going to be setting up our equations to find the value of x. So let's look at our complementary angles. We are adding these together. So 3x plus x plus 10 has to equal 90. Combine like terms. 3x and x make 4x plus 10 equals 90. Subtract the 10. 4x is equal to 80. We're solving equations. Divide by 4. X is equal to 20. Okay, so I just found out my first measurement. Next one, these are vertical, so these are equal to each other. So I'm setting these sides equal to each other. Move over the smaller variable value. So we're going back to our solving equations. Subtract 1, 3x is equal to 12, divide by 3, x is equal to 4. Next one, these are supplementary, so they have to add to equal 180. So I'm going to add them up, these parts right here, add them up, and set them equal to 180. Combine my like terms, 5x minus 5, because negative 10 plus 5 is negative 5, equals 180. Add 5 over, 5x is equal to 185, and divide by 5. I end up getting, need to grab my calculator, I end up getting 37. All right, we are going to meet at our team's meeting very soon. If you have extra time, feel free to get started on the homework or the IXL practice. But if not, I'll see you guys in a little bit.